Now I'm going to create a C# application that writes a lot of data to a compressed file. First, we're going to write it to a standard file so we can compare the size before and after. We know we're going to be working with the file system, so let's add the system.io namespace. First, let's demonstrate the use of the stream writer class. Obviously, there are many different ways to create a file, but stream writer is one you should be familiar with. I will simply specify the name of the file here. Now let's do a for loop to write hello world 10,000 times. We're going to call streamwriter.write to write it out. Now we just have to close the stream writer. Reading it in is just as straightforward. We're going to create a stream reader instance. I'll call it SR and specify the file name. We can simply call console.writeLine and specify the streamreader.readToEnd method. That just reads all of the data in the file as one big string. In practice, stream writer and stream reader can handle binary data and buffer arrays, but it's a little complex to actually read it. It's easier to write than it is to read, so you might end up using the binary reader and writer class instead. So once again, we just need to close it now that we've read and displayed the whole data. And just for fun, so we can see how effective the compression is, I'm going to create a file info instance and use it to display the size of the file, both compressed and uncompressed. Alright, so fileinfo.length is the actual size of the file in bytes. One last call to console.readKey to prevent the console from disappearing when we're done. Now I'll run it. Alright, that's a lot of hello worlds, and you can see that the entire file amounts to 129,000 bytes. So we're going to do that one more time, but this time we're going to use the GZipStream class, which requires the system.io.compression namespace. Now, to write to a compressed stream, you need to create the GZipStream instance and then use it when creating your stream writer constructor. We're going to specify file.create to specify the file name, and I'll just use the same file name. And you specify the compression mode, which is either compress or decompress. Because we're writing here, we're going to be doing compression. Now in the stream writer, instead of specifying the file name, I will specify the GZipStream instance that we just created. Alright, so that is sufficient to write the file. I also need to be sure to close the GZipStream instance. I need to do the same thing in order to read the file. I need to create a GZipStream instance and then specify that instance when I create the stream reader. Notice this time the compression mode is going to be decompress because I'm reading it in, reading a compressed file in and decompressing it. So once again, I'm going to specify the GZipStream instance instead of the file name in the stream reader. I don't need to change the code to actually read or write to the stream reader and writer because that's abstracted. Alright, that should do it. I will run it. and look at my bugs. Oh, I forgot a parenthesis. Yep, happens to everybody. Okay, we'll try this one more time. Alright, so this time, last time the file size was 129,000 bytes. Now it is 1,500 bytes. So you can see that was a ridiculous amount of compression. We got down to, what, 1.4% of the original file size. You won't normally see those kind of results, unfortunately, unless you're compressing a text file that just has the same text pattern repeated over and over. Then your compression is going to be ridiculous. If you were to try to compress a picture file, you would get almost 0% compression. Most data files will probably get 20 to 30%. So your results may vary, but if you're using text, it's most definitely worthwhile.